Thank you very much. So, let's talk about, not maths. Let's talk about chemistry. Woo! However, my problem here, friends, is that there's something coming around. It's like a disease that's starting to spread. It's called Gamophobia, and it means fear of chemistry. I mean, what the hell is all about that? Chemistry is amazing. Who the hell is scared of chemistry? But there are some meanies out there. There are some people who like to throw stones at chemistry. So I have two things to say to those people. Thing number one, my nickname at work is Muscles Murray, and I am coming after you, meanies. Thing number two is that the meanies sort of have a point. Because chemistry is killing us, but chemistry is also going to save us. So all of the big problems, things like climate change or climate change and crisis, and also human health, all of the problems are chemical. So, knowing that all of them are chemical, I'm afraid you're all just going to have to become disciples of the good science, disciples of chemistry. And to get that kind of going and to teach you the important part of being a disciple, because as we know, all good disciples have a creed, okay? We're going to have a bit of audience participation. Way! So, but before we do that, I'm going to give a special shout out at this point to my Irish Sign Language friends. You do not have to do audience participation at this particular stage. Instead, what you get to do is you get to laugh at us, and you also get to stare very intently at any of those poor fools. Oh, it's a good idea to swipe right on Tinder or pick their nose, okay? So, audience participation time. We are going to learn our creed. I need my hands for this. So, the creed is very easy, friends. Hands up, right? You ready? Here we go. Everyone needs chemistry. Okay? Nice and easy. So we're going to do it again, yeah? Everyone needs chemistry. Now, anytime Cormac and myself do this, you have some work to do, friends, all right? And the thing is, if you think I will not come down there and stare at you if you are not doing it, you are highly mistaken. I am a Borghini leader. I have been doing this for years. So, when we start to think about Trump and his fake tan. Oh, come on, you did very well. Everyone else is shit. Let's try again. Trump and his fake tan. Everyone needs chemistry. When we think about Gwyneth Paltrow and her chemical-free cosmetics, everyone needs chemistry. When we think about the industries who are melting our icebergs, everyone needs chemistry, okay? And we think about anyone with a mobile phone. Everyone needs chemistry. Very good, friends. Now, don't forget that because you will be asked later on. And thinking about things around chemistry, I'm going to talk about something I love, okay? So we talked about the climate crisis. We talked about the icebergs melting. We also talked about our health. These are connected by something that's called intermolecular bonding. Now, the name's Bond, intermolecular bond. So, what is an intermolecular bond, I hear you say? Well, it's really quite simple. Because if you think about atoms in the world around us, when they join together, right? When they get tied up in bonds with other atoms, they make molecules. Wink, wink. So, that's intramolecular bonding. Thank you, somebody. So that's intramolecular bonding. However, when molecules get near other molecules and they get a bit excited, that's an intermolecular bond, okay? And there are loads of different kinds. I'm going to start with the classic, okay? The classic is the hydrogen bond, okay? That's what keeps DNA together. That's what's holding all our ice together. And when you think about the hydrogen bond, I mean, it's basically just a hydrogen on one molecule getting very, very excited when it sees another oxygen and it's like, hi, friend. And when you think about them, I mean, they hold together so many things. They're really fundamental. Without them, we would die because everyone needs chemistry, right? So our hydrogen bond, we're thinking about this now. And one of the things I would say is that they're really fundamental, okay? They're really critical to life. And building on that, you say, well, basically, an analogy is that, like, there's sex, right? Hydrogen bonds are sex. And pushing a very bad analogy even further, we'd say that at least with hydrogen bonds, in ice, they've got 20 different ways of taking care of business, which means you're in good hands, all right? So hydrogen bonds are a good thing. Now, we'll go and start to think about this. Thank you, Cormac. And what I think at this point, you need to be extremely grateful that I decided to not push that analogy any further, because I was very tempted to do intermolecular bonding through the Kama Sutra and then decided against it, okay? So, you were very lucky people. However, we need to start thinking then about other kinds of bonds. Other kinds of bonds do exist. And those, let's start with halogen bonding, right? It's a very dark world, halogen bonding, because halogens are very negative, right? And it's only under very certain circumstances, very particular circumstances, that they will actually engage in this, okay? They'll engage in halogen bonding. Halogens, we go to the right of the periodic table. Hashtag IYPT 2019, people. Whoop, whoop. Yeah? Remember, everyone needs chemistry, okay? So, we are thinking about halogen bonding on the right-hand side. So we've got fluorine, chlorine, bromine, iodine, astatine as well apparently does this. Okay, they all engage in halogen bonding. And one of the things that I find quite interesting is thinking about them, right? They're really not the best elements to take to a party. Okay, you really don't want to, because, I mean, they're radioactive, right? One of them is at least. They're also smelly. They really, they like to just get everywhere. They stain everything. And then also, I mean, they're just a pretty lethal combination to have around occasionally. So they're a bit like an American president, we know, you know? So that's halogen bonding. I have a whole diatribe I could do on why I think actually chemists have a serious issue with halogen bonding, because they like to include hydrogen. Hydrogen has no place in halogen bonding. It can feck right off, okay? But that's one kind of bonding. We've also got another kind which doesn't mind hydrogen, and it also doesn't mind halogens. It's quite happy to have both. It's called dipole-dipole interactions, right? And they're really friendly interactions, because it's kind of like when one molecule is feeling a bit sad, right? It's a bit low. It reaches out its hand, it finds another little friend who's a lot more positive, and then they go swinging off into the future, right? So that's dipole-dipole. That's much nicer. But they're quite strong interactions, relatively speaking. There is also something else, though, that's a lot weaker, right? And given the current Brexit situation, I don't really feel like talking about London dispersion forces is going to go down very well. But I will say they're very weak, okay? They're really not the most reliable of forces. You wouldn't trust them to take care of things or to take a country out of the EU. Let's just leave it there, okay? Leave it there. And thinking then about other interactions, I now come to the point, so I'm hoping I have time, I'm assuming I have time to do this, because it's called, I get to speak about my favourite interactions. And they involve something that is called benzene. And now I apologise to poor Cormac here, because this is quite difficult to explain, because benzene is a beautiful molecule that contains 6 carbons, 6 hydrogens, and benzene is flat. And I get to give a shout out to my favourite scientist at this point, who is an Irish woman scientist who is brilliant. Okay, go home, Google Kathleen Lonsdale, the original Lonsdale, right? The original Lonsdale. Okay, she was the person who discovered that it was flat. And when we're thinking about benzenes, they really like each other. No, I mean, really like each other. And they're a bit like teenagers. Okay? Because they do 3 things. Thing 1, they headbutt each other. Thing 2, they stand very, very close to each other and gossip. Thing 3, they occasionally lie directly on top of each other and hang around for a while. And these are interactions that I basically spent my entire PhD in a dark basement doing, hunting them down like a very lesser grade Lara Croft. So I'm a little bit attached. And the thing I should say is that, you know, I've spent an entire set basically talking about these interactions, but chemists sometimes get so obsessed with the bonds in molecules that they forget that molecules also like molecules. And even me, I've occasionally forgot the intermolecular bond, and I am a #big fan. So it's something that I think we really need to be more careful about. And I mean, my most recent work is looking at something called calcium carbonate, right? It's in your kettles, it's in chalk, it's in paper processing, it's in food, right? Because everyone needs chemistry, right? Very good. So it's something that I had completely forgotten about in this context. I didn't think hydrogen bonds mattered. Turned out, in my particular chemistry, they do. That was a bit like a do. And actually what they do is they direct the different types of chemistry we're able to do. So that was a bit like a kick up the arse for me, kind of going, don't you forget us, we're here. And it's something that I think more people need to remember. Now, I think my time is possibly up. So at this point, I get to leave you, friends. And I feel quite sad about this because I feel like we've really bonded. I feel like our reaction has been wonderful together, you know? And I also think that, you know, as my disciples now of chemistry, you are going to go out into the world and you are going to remind everybody that everyone needs chemistry. Exactly correct. So, I've been Claire. This has been Cormac. You are now all members of the chemistry cult. Welcome, friends. We got all the drugs.